Alright, so we're going to look at solving a word problem using a quadratic equation with rational roots. So let me go ahead and grab the word problem that we're going to be working on. So here's the word problem that we're going to be working on. The word problem is the length of a rectangle is 11 yards more than twice the width, and the area of the rectangle is 63 yards squared. We want to find the dimensions of the rectangle. So we're going to take this stage by stage, and this is how you typically want to work through a word problem, is you want to break it up into segments. So the first segment that we want to look at, let me actually grab the highlighter here. The first segment that we're going to look at is the length of a rectangle is 11 yards more than twice the width. That is a phrase that we want to work with. The second phrase that we're going to want to work with is the area of the rectangle is 63 yards squared. Okay, these are both important pieces of information, and we want to make sure that we identify them in isolation rather than trying to solve this whole thing at once. So let's look at the white highlight first, where it says the length of a rectangle is 11 yards more than twice the width. What we want to do is we want to create an expression that helps us turn this sentence into a mathematical statement. So we know the length of a rectangle. Okay, so length L is, okay, so the word is means equal. Okay, so you can see here, here's is, here's equal. Okay, so we want to make sure we keep those in order. Now, let me erase this, hold on. Okay, so now we have length is 11 yards more than, okay, so when you have 11 yards more than something, what it's really saying is there's something plus 11, because that's more than, it's 11 more than, okay, it reverses direction. Twice the width, okay, so twice the width. So now when I read this, okay, and this is just practice, you just got to go through some of these multiple times to really see this, but when you look at this, it says the length of a rectangle, L, is equals 11 yards more than twice the width, okay? So here's my mathematical statement that is the exact same as the sentence that was highlighted in white. Now let's go down to this other one, whatever this color is. It says the area of the rectangle is 63 yards squared. Okay, so the area of the rectangle, I'm going to go sub R just so that I know, okay, I'm dealing with a rectangle, is 63 yards squared. Okay, so here's my two statements. Now, what it wants me to do is it wants me to find the dimensions. So it wants me to find the length and the width, right? So it wants me to find those two. Now, it could go the other way. You could say the width and the length. It really doesn't matter. You're just looking for the dimensions of the two. We do know what the area is, but we also know that the area of a rectangle has a very specific formula. That formula is area equals length times width. So, what are you noticing? I'm noticing I have a length and I have a length right there. I also notice that I have an area of a rectangle and an area of a rectangle. So I've got some values here that I can work with. So what I'm going to do is I'm going to substitute or plug in these numbers and these expressions into this formula. Okay? So a lot of times when dealing with word problems, you're looking for a formula that you can substitute other elements into. Okay? So now we're finally to the solving part, and this part goes fairly quickly. So let me just scroll this up. And here we go. So we've got the area of the rectangle, which I know is 63, and that needs to equal the length. Well, I know the length is 2 widths plus 11, and it is going to be multiplied by W. Okay? Now, I'm going to rewrite this just a little bit because I want to see it in a different light. It's going to actually be 2W plus 11 parentheses W. That times just turned into a parentheses, okay? And that is perfectly valid. You can do that. Well, now looking at this, this is obviously, oh, this is a distribution. Okay, so that's nice and easy to work with. So I go 63 equals 2w squared plus 11w. This is now starting to look like a quadratic equation. What I'm going to need to do is I'm going to need to subtract the 63 from both sides. And let me just scroll this up a little further. So now we've got 2w squared plus 11w minus 63, and that all equals 0. What I would suggest at this point is that you use the quadratic formula to be able to solve this, unless we can come up with a way to factor it down. But in my personal opinion, quadratic formula is going to be the best approach at this point. So we're on to our next step. So I'm going to scroll this up. We are now just dealing with that equation. Well, I know that the formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I know that my a value is 2, my b value is 11, and my c value is negative 63. So I'm going to go ahead and start plugging all this in. It's going to be equal to negative 11 plus or minus the square root b squared, so 11 squared minus 4 times a times c. So this is going to be a huge number, and we are definitely going to want to use a calculator for that. So we're going to get negative 11 plus or minus the square root of 121, and calculator time, negative 8 times, sorry, let me do this. It's negative 4 times 2 times negative 63 is the way we want to say that. So this is going to be plus 504 all over 4. Okay, so this number's just getting bigger and bigger and bigger. Holy moly. Okay. By the way, that x, I apologize, that x is not an x. That x is actually w. Okay. So that's what we're looking for. We're looking for the w. Excuse me. So now we're going to go 121 plus 504, which is equal to 625. So we have equals negative 11 plus or minus the square root of 625 all over 4. So we're going to take the square root of 625, square root of 625. That gives us 25. So we have negative 11 plus or minus 25 all over 4. Now, the thing here is this now breaks into negative 11 plus 25 over 4 and negative 11 minus 25 over 4. This one will not make sense because we'll get a negative distance, and you can't have a negative distance when dealing with a rectangle. It has to be all positives, so therefore we can automatically eliminate that as an option, and we focus on negative 11 plus 25, which is going to be 14. Okay, so let me just zoom this down real fast. Okay, so now we've got ourselves equal to negative 14, sorry, positive 14 is what I meant to say, over 4. And we can simplify this by dividing both top and bottom by 2. And we've got ourselves 7 halves. 7 halves can also be written as 3.5. So my width is equal to 3.5. So I've got part of my equation, but remember from the top we knew that length was double the width plus 11. So we're going to go 2 times 3.5 plus 11. So 2 times 3.5 plus 11 is 18. So your length is 18. All right? And so that is the process for solving this problem. So you'll have a length of 18 and a width of 3.5. You could have also done a factoring process on this one. Okay? So I'm just going to slide this to the side here, and you could have done, rather than using quadratic formula, you could have factored. Sorry about that. My pen doesn't want to write. could have done a factoring method, which would have given you, would have taken you from 2w squared plus 11w minus 63 equals 0. You would have looked at 7 times 9, okay, and you would have looked at 2w times w. Well, 2 times 9 is 18. 18 minus 7 is 11. So this would have gone 2w, w, because whatever's at the front stays at the front, whatever's in the back goes to the back, and you're going to have 7 and 9, and this needs to be a negative and a positive, equals 0. And from here, you could have set it equal to 0, set this one equal to 0, and you would have gotten a width equal to 7 over 2, or a width equal to negative 9. Negative 9 makes no sense, so this is gone. There's your w equals 7 halves, which is the same as 3.5, and you could have found length to be equal to 18 from that as well. Okay, so 2 different methods. You have to just decide which one works best for you. I like quadratic formula because it works consistently.